Okay, so in this class we will discuss about the loading part of the Staad Pro, all the loadings. Here I need a project, so I'll try to start a new project for loading. I'll go to Geometry Run Structure Wizard, and here we'll try to go for a frame load, bay frame, click on Apply. Then you go to File, Merge Model with the Staad Pro model and give Yes and give OK here. On this we'll try to discuss various types of loadings. Obviously there will be a property required, so we'll try to define a simple rectangular property of 0.6 by 0.23. I'll try to add and close. I'll click on assign to the view. I'll go for the front view where we'll be giving fixed supports after creating it. Then we go for the loads and definitions. As I have told, there are two loads: definition loads, non-definition loads. First we have to apply definition loads. So here we have got various types of definition loads. Generally we will be applying definition loads like wind load, seismic load only. We have other definition loads like we have pushover definition, direct analysis definition, which is used in the MTech level. Okay, if you have not known the theory, you won't be able to do it. We have reference load definitions, we have got time history definitions, we have vehicle definitions, and other different types of load definitions which we can use here. So first we have to develop a definition load, then we have to go with the load case details and apply that load value. Okay, we have to apply that load value. So we'll try to discuss different types of load value in this case. So I'll go directly with the load case detail and try to add dead load, and here I'll add dead load. I'll try to take dead load, and in that I'll try to add self weight. Now you understand self weight means if you have got beams and columns, beam and column weight will be automatically added. Obviously slab is not added here, that's why we have to add slab load extra along with the flooring, that will be also extra. If you have added a plate and given thickness to it, you don't have to add slab load. I'll be adding all other load types and other dead load only. Here we have got nodal load where we can add a load at a point or a node. I'll take Fy direction, let's say I'll take minus 10 kilonewtons. I'll try to add and close. We have got minus 10 kilonewtons. I'll now take the node cursor, select a particular node and assign to the selected node. I'll try to assign this value to the selected node and then we'll click yes. You can see here we have got minus 10 kilonewton going to those two nodes that I have selected. Then we go for the load case details, click on add. We'll go for the dead load and then click on add. Here we'll go for the member load. We have discussed about the normal member load by adding wall load on the structure. We have added minus 10 kilonewtons. Now if we give d1 distance, the starting distance, let's say d1 distance is 1 meter, d2 distance, the length of that will be not more than 2 meter, and d3, the projection I am keeping 0, so it will be at center line. So I'll click on add and close, and here we have got this. Now what we will do is we'll try to take the beam cursor, select the beam and try to assign the selected load on the beam. So you can see it will start with 1 meter and go up to 2 meter. It will start with 1 meter and go up to 2 meter only. Okay, so this is about the projection, this is about the load here. Now I don't need this one, so I'll try to delete this one and I'll try to delete this one. Self weight is required, so we'll keep that weight. I'll go with the member load again. We have got uniform moment. Like uniform force, you have got uniform moment. One more thing we will try to discuss in this. Here we can see the global direction. Now you understand global direction means it will be perpendicular, or it will be in a line with the global x, y and z axis. What is local direction? We'll try to see what is local direction. Let's say here I'll try to add one. I'll just take a node here. I'll just take one node, go for transitional repeat. I will repeat in y direction. I'll repeat it by 2 meters in upward direction by linking the step. and then we'll give OK. Then here we'll try to take add a beam, and I'll add a beam like this. So I have got an inclined member there. Now I will add some property to this two beams. Let's say the same property that we have assigned before. If I reassign the property, it will not do any changes, so I'll just try to select this and click on assign to view. So it will be assigned to the whole structure. Now we'll try to go for assigning some loads here. Now what we will do is we'll try to go for the load definitions, click on load case details and take the dead load, click on add, and here we'll try to add member load of, let's say, uniform force. Let's say minus 10 kilonewton. Also here we are adding, let d1 d2 d3 will be 0. I will be applying again in global y direction. Select one beam, and select assign to the selected beams. You will find it will be perfectly vertical. But if I try to edit it and change it to local y and change, you will find it will be perpendicular to the beam, not to the surface. So this is local and global direction, means it follows the direction of the beam, not the direction of the, that is, global direction. Similarly, projected direction we cannot see. We cannot see the projected y directions and all, but you can see it will be vertical, but it will be little bit away from the center. It is not projected exactly on this beam, it is little bit away from the center. That is called projected y direction. So here we have got, okay, so here we have got this projected y direction. So here now what we have seen is projected y direction will be explained using the internet. So I don't have the reference manual or any PPT, so I'll explain you using this one, projected directions in Staad. I'll go with projections direction in Staad, and here we'll try to see projected load on plate elements in Staad, member load, type, projected length. So it is nothing but the projection of the member, means if it is not exactly acting at the center, if it is acting away from the center, then what is called projected load. We'll try to see if we have got some images related to that. You can see this one. We don't have a proper image that is depicting the projected load, means if I try to see this one, slightly explains. You can see the projections. Okay, the load is not exactly at the center, but it is little bit away from the center. That is called projected load. So you can see projected load on the plate element in Staad. Similarly, we can understand with the member elements also. Apply projected load on the angle plate. So it is nothing but you can see GY. I'll just see if we have got projected load. Now Px, Py, Pz indicates load along the projected length of the member in the corresponding global direction. However, d1, d2, d3 are still measured along the length of the member, not along the projected length of the member. So it doesn't explain exactly what is projected length. It is means if you are not allowing the load to be exactly at the center of the beam, then that is called the projected length. If you are not allowing the load to be exactly at the center of beam, that is called the projected length. Here we have slight explanation that indicates the load along the projected length of the member in the corresponding global directions. Projected length means in a particular direction, if length is projected or extended, then along that it will be added. For example, if uh, a glass is hanging on the beam, okay, glass, you can see the glass panel, we call it as curtain panel. Curtain panel is hanging on the beam and it is away from the, it will be not exactly kept on the beam, it will be it will be using a hook, and then it will be exporting outward. So I'll show you the curtain panel attached to beam. we'll see. So that curtain panel here we have got something here. Now in this picture you can see this is the beam and this is the concrete panel or curtain panel. It is not exactly at the center of the beam, it is projected outwards. That is called projected direction, projected outward projection. Okay, it is not exactly at the center of the beam. Here also you can see these glass panels are not exactly kept on the beam, it is projected outward with the L angle. This is called projection outward. Okay, so this is about projections. So if you have in that case, then you go for projected directions. Okay, we will go for adding some more loads. So we go for the member load. Here we have seen the uniform force, we know all the directions now. Similarly we have moment is about particular axis. Okay, about y-axis, about z-axis. Suppose if you give a uniform moment of -2 kilonewton, it is also exactly at the center in the global y direction or along global y direction. I'll try to add and close. Now I'll try to select a particular member, assign the uniform moment for this particular member. I'll click on assign to the selected beam. We can see if it will be about y-axis, horizontal. About y-axis means it is vertical axis about which it is rotating in horizontal direction. That is called about y-axis rotation. So again we'll try to take dead load, click on add. Then here we have got member loads where we have got uniform moments. It have the similar way of applying like uniform force. Then we have the concentrated force. You understand by the concentrated force, for which also we have to give d1 and d2 value. If you don't give any value, it will be exactly applied at the center of the beam. And then we have again local direction and global direction. It cannot be applied to the projected direction. Let's say I want to have around -5 kilonewtons in global y direction. I'll try to add and close. I'll select this one. I'll select a particular beam and assign to the selected beam. Here I'll click on assign to the selected beam. So it will be exactly at the center. Now what we can do is we can go for edit and try to change its d1 and d2 value. Let's say I want d1 to be around 2 meters. I'll click on change and you can see it will be shifting by 2 meters here. So this is how the the global directions or the loads will be applied. The concentrated load will be applied. I'll go with the dead load again. I'll go with the member load here. We have seen the concentrated moments. Similarly, like concentrated force, we have concentrated moment, but it is about a particular axis. Okay, it will be about our axis as we have seen in case of uniform moments, for which you have to give a value. Let's say -2 again. And if you want, you can give this value, click on add and close, select a particular beam and select this load and assign to the selected beam and click on assign. It will be, you can see it will be rotating in the horizontal direction about vertical axis, not along that axis. Then we go for the dead load again, click on add, and here we have got the member loads. We have seen all this. Then here we have got linearly varying load, means along a length it is varying or changing, where we have to give w1 and w2 value. This is also called a sometime trapezoidal load, but trapezoidal load we have a different case already, so we'll try to use this little bit later. Here we have got linear varying load, along the length it is varying, that is called a linear varying load. So along the length if it is varying, so what we have to give, we have to give w1 value. Let's say I'll take -2, minus for negative direction or downward direction, and we'll try to go up to -10 in the local y direction. It can be only applied locally. Click on add and close. We try to select a particular beam. So here we'll try to select a particular beam and then we'll try to go for assign to the selected beam. I'll select this one, select this beam and click on assign to the selected beam, and then we'll click on S and click yes. Okay, you can see it will be applied along the local directions only. It will be not applied along the global direction or the vertical or the angle that is parallel to X, Y or Z axis. Then we'll go with the dead load, click on add. Here we'll try to go for the member load, we have seen the member load. We have got the linear varying load. Another type of linear varying load is this one, where it will be 0 at the ends and highest at the center. W3 will be 0 at the ends and it will be highest at the center, that is here. Okay, let's say here I'll try to go for minus 10 kilonewtons, and then here we'll try to add and close. Then we try to select a particular beam and click on assign to the selected beam and click on assign and click yes. You'll see it will be applied like this, like a triangle. It will be highest at the center and linearly it will be varying to 0. Then we go for the dead load again, click on add. We have seen in the member load, we have seen the linear varying load. Here we have got the trapezoidal load. Trapezoidal load have d1 and d2 values also. Other things are similar to linear varying load. Other things are similar to linear varying load. In the trapezoidal load, d1 and d2 changes like the uniform forces. For example, I'll take minus 2, I'll take minus 10, I'll go for this value, starts with 2 and go maximum up to 4. In the global y direction, click on add, select this one, assign this to the selected beam, and click yes. You can see it will be going like this. If it is coming out of the beam because of the distance that you have given, then it will be not applied actually in the analysis. So we have to change it. What we have to change? We have to change this to 4 and we have to change this to 2 because the direction is different, and also starting and distance. So this is the d1 and d2 value. The values has changed, but still we are not able to get it correctly. We have to give these values correctly. For guessing the values correctly, first you see where it is starting. This is the starting position, this is the ending position. Total length is total 3 only. Okay, I think 3 meter only or 5 meter. That's why it is coming out. You have to give smaller values. So we'll try to give smaller values for this. Let's say I'll go with the 1 meter and go up to change and see where it goes. You can see now it goes to the center. So this is how we can apply different types of loads under the members. So I'll go for add, then we go for the member load. Here we have got trapezoidal load, then we have got hydrostatic load. Hydrostatic load is also a trapezoidal load. Okay, and that is also applied along the length of the member, but it is applied vertically as shown in the figure. For that you have to select some members. You can select the members by clicking on them. If you want to select multiple members, you have to press Ctrl and select them, and then you have to click on done. They will be seen here. Value should be given. Again, value should be given carefully. Global y direction is vertical, but I have selected vertical members. That's why it should be either global z or x in order to see it. I want to apply 2 kilonewtons and around 5 or 6 kilonewtons. Okay, interpolated in global axis, y axis, in which direction? So here we have the direction and interpolation, which will be changing after editing it. For now I'll keep it default gy and y. I'll click on add and close. Now you can see here we have got a trapezoidal load, but I cannot see this because it is under the y direction. If I try to edit it, what we can change is the direction. So I'll change this one. Now you can see it is interpolated. Means it is varying vertically. You can see this one, particular load. You can see this one, all are different. I have only changed this one, or the first one. Okay, I have changed only this first one, sorry, second one. Okay, you can see the value. This is the first one and this is the next one that I have changed. Okay, so if I select this one, it goes to green. This is blue, I cannot see it, so I'll try to edit it and give global z direction. Change, it goes in another direction. You can see here it has got global z direction. Global z direction is this one, interpolated, or this direction. Okay, so this is hydrostatic pressure. usually applied for a load like water load. It is usually applied for a load like water load, that is called hydrostatic pressure. Okay, so now we'll go for the dead load again. Click on add. Here we'll go for the member load. Then we have got pre-stressing and post-stressing. Sometimes member are pre-stressed and post-stressed. Means we have got a concrete structure, we pull it and then leave it, so we give some stress to it. Okay, let's say we give minus 1000 kilonewton stress. Okay, eccentricity distance. Eccentricity means I'll explain you what is eccentricity. I will use paint in that case. Here we have got beam like this. Suppose we have got this beam, then what we do is we put a wire inside this. We put a wire inside this, and that wire goes like this and goes up. This is, let's say, center axis. This is the center line. So this length, this distance here, this gap is called eccentricity. This particular gap is called eccentricity. Here eccentricity is 0, and let's say here eccentricity is x value. So this gap is called eccentricity. This is the center line. This is the center line, and this is cable. This is cable that goes from starting point to ending point. Okay, so I'll just close this. I'll not save these changes. I'll give no. Here we'll give start 0. Let's say end will have around 50 or 100 mm. Minus will be denoting the negative direction. Okay, and then will be 0. Then pre-stretching means previously we are stretching. Post-stretching means after stretching, means first we are inserting the cable, let the concrete dry, and then we are stretching. That is called post-stretching. So pre-stress and post-stress. Okay, click on add and close. So this force can be applied to any beam by assigning to the selected beams. Then click yes. Then we go for the dead load. Click on add. Here we have seen member load. We have got fixed ends for a beam at the nodes, starting node and end node. We apply some load forces. Let's say minus 10 kilonewton here, and we'll apply minus 5 kilonewton here. Then we'll try to add, close. Select a particular beam, assign to the selected beam. Click yes. So at two nodes of this particular beam, these loads will be applied, minus 10 kilonewton and minus 5 kilonewton. Select any beam, vertical beam, assign to the selected beam, and loads will be applied. Because here we have got two beams, that's why they are not seen, but they are applied. So this is all about the member load. So here we have understood about all the member loads. Under the loads and definitions, load case details, we have got loads here, and we have seen the dead load. We have clicked on add, and we have got member load, and we have used all the member load. Member load is like physical member load only. Physical member load and member load are both are same, but we have to make a physical member. Generally we don't make physical member in case of normal Staad Pro analysis or design. As we have seen, we make member load when we use RC designer. Okay, so it is not generally used when you have got 3-4 beam together, combined together as one beam. Then we can apply that load on that physical member. Okay, but we don't use that generally. That physical member we don't use, that's why it is not used. But the loads are applied in the similar manner. All the loads are same. Then we have the area load. Area load is not for the slab, it is for the beams and columns. Area load, let's say pressure, I'll give minus 2 kilonewton, negative direction, in the global y direction, negative in global y, or you can apply local z. It is like plastering load on the beams and column, that is called area load. Okay, plastering load on beams and columns is called area load. Then we have got the floor load, which we have already discussed in detail, where we have to give pressure and the range option for applying uniformly distributed load on a particular slab. It is generally used when you have got uniformly distributed load. For example, here we don't have slab, so I'll take minus 25 kilonewton applied to the full structure. So I'll take any value more than the height of the building, click on add and close. Now if I select this, you can see the loads will be applied. I'll try to edit and try to change this value little bit so that I can see the value. Let's say I'll take -10 only just to see how it is applied. I'll further change it to smaller value so that we can see the results. So you can see it is a trapezoidal distribution of load. If I go for editing, if I edit this range to 6 meters and change, it will be applied only to 2 floors. If I go for editing and change this to, let's say, 6 meters, so in next range we'll have only this much, 2 slabs, because it is 3 meters. Then we can also change in z direction, let's say 3 meters, so it will be only applied to 3 meter slab here. 3 meter is this direction, this much is 3 meters. So we can limit in which slab it will be applied by giving a range option. Range option is used a lot of times in Staad Pro. So under dead load we have added the floor loads. Then we have got plate load, which we'll be discussing in the next video.